In this video, let's talk about Android devices Wi-Fi roaming. This is the last video in my series about different operating system devices roaming behavior. I'm going to use a Google phone for the testing. On Android.com, there's a very good document about Wi-Fi network selection. Basically, it's another way to say Wi-Fi roaming. I strongly recommend you to read it through if you are interested about Android devices Wi-Fi roaming. We don't have enough time to talk about all the details. For your convenience, I prepared a diagram about the basic steps described in this document. By the way, this video will only be focusing on the scenario where your device screen is on and is connected to Wi-Fi network and your Wi-Fi network's band is 5 GHz. For different scenarios, you may have different thresholds and different conditions. So let's focus on this most common scenario. So the first step, your device need to decide whether your current network is good enough. That's a very interesting way to describe your Wi-Fi condition. How Android decides whether your network is good enough. Three most important conditions. First, whether the last network selection process happened within 10 seconds. If yes, it won't do the so-called network selection. It will go back and wait. The duration is every 10 seconds. The second condition is very important. That's the so-called Wi-Fi roaming trigger threshold. So for Android, for 5 GHz is minus 70 dBm. If you watched my previous video about iPhone, iPad, and macOS, you may remember for iPhone and iPad, the trigger threshold is minus 70, and for macOS, it is minus 75. So Android has the same trigger threshold as iPhone. The third condition is even more interesting. It's saying whether your device is very busy, whether it's using the Wi-Fi network heavily. If yes, you may not want the roaming to happen, even though your Wi-Fi signal strength is very weak. How your Android device decides whether your Wi-Fi traffic is heavy or not. Every second, if you have more than 16 packets, your device will think about it. It will not start roaming. Later in the video, when we do the testing, we will do this minus 70 dB testing and this busy traffic testing. Okay, move on. If your device think, okay, your network is not good, it will try to start roaming. It will use the network nominator to generate a list of candidates. It will do some basic filtering. If the Wi-Fi signal is weaker than minus 77, it will not take it as a candidate. That makes sense, right? We are talking about roaming. Of course, you don't want to roam to another bad signal access point. So once you get the list of candidates, it will run the candidate scorer to do the sorting and then choose the best candidate. This step is similar to, let's say, in Linux. If you run WPA supplicant, it will have the similar process. It will give score to every access point and pick the best one. So once it gets the candidate, it will run an extra step. It will check whether you have your preferred choice. The system may roam to the candidate which is not the best, but it's your preferred. So basically that happens when you have a stronger access point, but it's broadcasting other SSID. You may not want to roam to that. The last decision is about, okay, now you get the best candidate. Whether the best candidate is already the same one your device is connecting to. If yes, all the steps are wasted, the roaming won't happen. If the system gets a candidate which meets all the conditions and is better than your current one, the roaming will start. Now you may ask, are there any ways to customize those numbers? For example, this trigger threshold minus 70, can you change it? The answer is yes and no. Let me explain that. This is the Android source code. If you go to Packages, Modules, Wi-Fi, and go to Service, Wi-Fi Resources, Resource, then the last folder, Values, there's a file called Overlayable. For example, for the -70 trigger threshold, if you search this string, config Wi-Fi framework, Wi-Fi score, low RSSI threshold, 5 GHz, it is the key to change, to customize this value. But unfortunately, this change is not for any user on their devices. If you check the comments, these values can be used to control the Wi-Fi stack behavior on individual devices. They can be overwritten by OEMs by using a Pro overlay app. This is why those type of values are called overlays. This is my lab environment. I use 2 UniFi access points. I will handhold this Android device, a Google phone. By the way, it's running Android 13, I believe. I will start from this access point and move to the other one. In the process, I will hold another laptop which will run sniffer so that I can capture the Wi-Fi frames. Later, we will look deeper using Wireshark. This is the UniFi network controller. Let me show you some access point side settings. About the SSID, I only have one enabled at this moment. I manually set it to only run on 5 GHz and I disabled all the fast roaming settings. If you go to the individual access point, for example, this U6 Enterprise, go to setting. As you can see, for 5 GHz, I manually set it to use 80 MHz channel width and set the channel to 36. The other access points, the same 36. In real world, you want to avoid the same channel for multiple access points, right? But in this testing, because I'm going to run sniffer, so to make the Wi-Fi frames capturing easier, I choose to set them to the same channel. It won't change the conclusion, but it will make the testing simpler. Another very important setting is the minimum RSSI. As you can see, I set it to a very low value. You may know when the roaming happens, it may be caused by 2 different reasons. One is the access point cannot tolerate the weak signals from your device, kick your device out. And the second possible reason is your device feels the signal is too bad and it chooses to roam. It takes initiatives. In this video, we will focus on the second reason. Your Wi-Fi device takes initiatives. So I want to exclude the first factor, which is the AP may kick your device out. So that's why I set the minimum RSSI to a very low value, so that long before this threshold is reached, your device should have already roamed by itself. Okay, this is the simple backend setting for the 2 access points. Let's start the first testing, which is to validate this trigger threshold, -70. For the second half of the video, we will check this scenario where we have very heavy Wi-Fi traffic. Let's see whether the roaming will happen, whether it will behave in any different ways if you compare to light traffic situation. Okay, let's get started. On the phone, I'm running the UniFi Wi-Fi Man app. Currently is connected to the U6 Lite, the left side one access point. I just started moving away from the left side AP towards the right side one. The Wi-Fi signal is dropping, but now it is still above -70. Keep moving. As you can see, the roaming hasn't happened yet. That's expected. Okay, it started dropping under -70. Okay, see, the roaming happened almost immediately. It's very smooth. Let's take a look at the captured Wi-Fi frames. This is the captured wireframes opened in Wireshark. Let me first filter on the protocol to EAPOL so that we can find out when the roaming happened. Okay, so there is only one set of 4-way handshakes. That makes sense because the roaming only happened once, right? See the first column for time. It happened at about 37 seconds. Let me change the filter. The filter I'm using is I want to see all the frames from or to this Android phone. So remember the timing when the roaming happened at about 37 seconds, right? So let me scroll to that point of time. This is when the roaming happened. Starting from this packet, the Android phone sent a broadcasting request. It's a probe request asking about information for this SSID, and it received multiple responses. The A8 was from the enterprise access point, and the B6 was from the U6 Lite access point. When the authentication really happened, almost immediately after the Android phone received the response. That's the same behavior if you compare to iPhone, much better than what Linux behaved in my previous video. Then no surprise, after the four-way handshakes, the roaming was successful. So the whole process was very smooth. That's exactly expected based on the threshold according to the Android document. There's one thing I want to check. That's about neighborhood report. If you want to know what I'm talking about, please check my previous videos in the same series. So I want to understand whether the Android phone also implement the IEEE standard for neighborhood report. The way to check it, I want to filter the frames using this type of code. I want to see the neighborhood report request and the response. Unfortunately, there was none. So that's disappointing and interesting. For Apple devices, they all implemented the 11K neighborhood report, and for Windows, the same case. But for Android, I haven't seen any official documents about whether it's implemented by default, but at least in this particular testing, I don't see any neighborhood report. Even though the whole process was very smooth, it is still a surprise. Okay, enough about the first simple testing. Let's move on to the second one. I launched a new Linux virtual machine and run iPerf 3 server there from the Android. Let me start the iPerf 3 to connect to the Linux just to simulate a scenario where we have very heavy traffic. This time, I'm moving away from the right side access point, the U6 Enterprise, towards the left one, the U6 Lite. From the Android machine, you can see currently it's connected to U6 Enterprise, and because I am moving away from the right side AP, the signal strength is dropping. Now it's already under -71, but it just keeps dropping without roaming. Okay, so after a while, finally it roamed. The roaming did happen. Apparently, compared to the first testing, you can see the roaming had a fairly long delay, more than 10 seconds delay. So let's see what happened from the captured Wi-Fi frames. Okay, I opened the captured frames in Wireshark. Let's check when the roaming happened. So I already filtered on EAPOL. You can see the four-way handshakes happened at about 44 seconds. Then let's see the frames related to the Android phone. Remember the timing for roaming? It happened about 44 seconds, right? So let me scroll to that time. 44 seconds, see the authentication, that's when the roaming started, right? Before that, you can see the probe request. It sent out about half seconds before the roaming. It received multiple responses from the AP. That's how the Android phone decides which AP to roam to, the so-called network selection, as explained in the Android document. Remember, we were running the heavy traffic iPerf 3 testing at the same time, right? Just to refresh your memory, see the very first decision step. If the traffic is sufficient, which means above 16 packets per second, the Android phone will still treat the network is good enough. It will not take any action. It will not roam, right? So let's do some data profiling. Within 42 seconds, there were 13 or 14 frames, lower than the 16 threshold. Then let's check 41 seconds, 15 frames, still lower than 16, and 40 seconds, 17 frames, just above the 16 threshold. So if you move earlier, let's take a random one, let's say 34 seconds. Yeah, it's higher than 16 frames for sure, because the signal was worse and worse. At some point, a lot of frames will be lost. That will result in a situation that even your device tried very hard, it still cannot achieve 16 packets per second. So that's why the roaming happened after 10 seconds, because the signal strength dropped to a very bad level already. At 34 seconds, the signal was not very bad. That's why it still can achieve more than 16 packets. So far, no surprise, but let's see when the signal just dropped below -70, about 30 seconds. Let's see at that time whether the Android phone did anything. For example, send out the probe request or not. Let me scroll to about 30 seconds. No, at this time, there's no any probe request. So which means even though at this time, the signal strength was already bad under -70, just because the phone was busy working on the Wi-Fi traffics, so the Android phone didn't start the network selection and the roaming process at all. It chose to wait for more than 10 seconds. Okay, this is the end of the video. Thanks for watching.